Hello, I'm Dr. Cheryl Dunn, and I'm here to demonstrate an intermediate financial accounting problem for a fictitious company called Gopher Lakers, Inc. Gopher Lakers, Inc. is trying to buy some equipment, and they have two different payment options, and our job is to help them choose between these payment options. The first option that they're given is that they can pay $60,000 now, we'll call this option 1. And then they can pay $5,000 per year for the next 4 years. So that's option 1. Option 2 is to pay $50,000 today, and then to pay $12,000 a year from now, $10,000 2 years from now, $5,000 3 years from now, and then $3,000 4 years from now. As you can see, both payments add up to a total of $80,000, but the timing of them differs. And because the time value of money matters, we need to figure out which is going to be more advantageous for them. We are told that the relevant interest rate is 7% annually, and we're asked to figure out, based on present value considerations, which of these two payment options we would recommend, and we'll make the recommendation based on which one has the lowest present value. So first of all, option 1. Option 1, $60,000 now, is already at present value, so we don't need to make any adjustment for that. And then we recognize that this $5,000 payment for each of the next 4 years is what we call an annuity. So we have a $5,000 annuity, and it's an ordinary annuity because the first payment is going to start after 1 period. And so we're going to find the present value factor of this annuity given an interest rate of 7% and a time period of 4. So we're getting the present value of an annuity factor at I equals 7 and n equals 4. If we look that factor up in our tables, give you a minute to look at the table. We find that that factor is 3.38721. And if we multiply $5,000 times the 3.38721, we get $16,936.05. If we then add to that the $60,000 that we would be paying today, we find that the total we would be paying under this option is $76,936.05. That's the present value of this payment option. Next, we're going to calculate the present value of option 2. And because the payments are all different amounts across those 4 years, we don't have an annuity situation. An annuity is equal payments spaced equally in time. Here we've got equal time frames, but we don't have equal amounts. And so we have to look at each one of these separately. And so for each one of these, we're going to multiply them by a present value factor. We're going to use the interest rate of 7. So we'll be looking at the present value of a dollar table, and we'll be looking at I equals 7, and then n is going to be 1, 2, 3, and 4 respectively for each of the relevant periods. And so we'll find the factor of present value of $1 at 7% and n equals 1, and we'll multiply that by the $12,000. We'll find the present value of $1 where I equals 7 and n equals 2, and we'll multiply that factor by the $10,000. And then so on and so forth for n equals 3 and n equals 4. So let's take a look at the tables. First of all, the $50,000 is already at present value, so we don't need to use any tables for that. The present value of $50,000 today is $50,000. The present value of $12,000 1 year from now is going to be the $12,000 times the present value factor at n equals 1 and I equals 7, and that factor is 0.93458. That gives us $11,214.96. So we'll put a little asterisk there. Then we're going to take the $10,000 and we're going to multiply that by the present value of $1 factor at I equals 7 and n equals 2. And that factor is 0.87344. And if we multiply 0.87344 by $10,000, we get $8,734.40. We'll put a little asterisk by that. Then for the $5,000 in year 3, we're going to multiply by the present value of $1 factor where I equals 7 and n equals 3. That factor is 0.81630, and if we multiply that by the $5,000, we get $4,081.50, and we'll put a little asterisk by it. And then finally we take $3,000 times the present value of $1 factor at I equals 7 and n equals 4. That factor is 0.76290, and when we multiply 0.76290 by 3,000, we get $2,288.70. And we'll put a little asterisk by that. We'll also put an asterisk by the $50,000, and the reason I'm putting these asterisks is that we're going to basically add up the various asterisks. And so if we sum, this is our summation symbol, the various asterisks, we come up with a total of $76,319.56. These are the two numbers that we need to compare to each other, and we can see that $76,319.56 is a lower cost option than the $76,936.05. And so this option 2 is the option that we would choose because that has the lowest present value of this cost. That concludes our demonstration of Gopher Lakers Inc. Thank you for watching and have a wonderful day.